A very good morning to all of you. This is the lecture 24th for the Power System 2 subject. So, in the previous lectures, we had started regarding the discussion about various types of lightning arresters. So, previously we had discussed lightning arresters are basically used to provide the protection against the traveling waves which are originated due to the lightning stroke surges. So earthing screen and the ground wire protection scheme is not capable to provide the protection against the traveling waves. So lightning arresters are mostly used to provide the protection against the traveling waves, which can cause a serious damage to the equipment in the substation named transformers and generators in the power stations and many other meters connected in the control room if traveling waves reach their terminal operators. So in order to provide the protection against the traveling waves, uh, there are various categories of arresters used. So in today's topic, we are going to discuss regarding the horn gap arrestor. Like in the previous arrestor, that is the rod arresters, rod gap arresters. Uh, I had earlier said that on the name of the arresters, ठीक है, जो arresters का नाम होता है उन पे ही उनका काम होता है. ठीक है, रॉड गैप arresters में what you have noticed, there are two rods bent at right angle to each other and separated by some distance. When an over voltage occurs on the power system, arc gets stuck between the two metal rods. ठीक है, and the over voltage or over current is flown through to the earth because one end is connected to the line and second end is earth. So likewise, horn gap arresters are, but due to the certain limitations in rod gap arresters, we use it as a second line of defense because the metal rods get melted or when the surge goes out, the arc cannot demolish fully. It will take a larger time to demolish the arc. So there are many limitations. So that rod type arresters can be used only for the backup protection. So in today's topic, we are going to discuss regarding the horn gap arresters. As the name suggests, horn. So there will be a horn type structure. This is a horn type structure and resistance and inductance RL series circuit is used. So during the normal operating conditions, there is no arc developed between the two horn type structures. But whenever a fault occurs, the arc gets stuck between the two horn structures. When it goes upwards, it will go on increasing and increasing because arc heated the air surrounds it, so it push upwards towards the sky, and this is shown by the dotted line. So when the surge goes out or demolished, the arc is also demolished because there is no current intensity left behind to maintain the arc. In spite, it has many advantages, whereas inductance also oppose the change in current during the normal supply frequency, resistance also control. So there will be no current after the surge disappears, but current appears in case of metal rod arresters. So when the surge goes out during the normal power supply frequencies, arc is not developed between the two horns. If it may develop between the two horns, it may not reach up to the third point, or it may demolish in the first point only. The major disadvantage is if there is a bridging between the two horns, it may cause a serious short circuit conditions if there is a bridging between the two horns. Okay, this arrestor will fail, or if due to the moisture content in the air, the metals used in the horn may get demolished. So due to these above limitations, the horn gap arresters are basically used as a second line of defense to the main arresters. Okay? So the let us discuss another category of arresters, that is multi-gap arresters. So in multi-gap arrestor, Look at one thing. The principle of operation for all the arresters remains the same. The only difference is in the constructional details. Principle of operation remains same. The only difference is the constructional details. So in the multi-gap arrestor, one end is connected to the line or to the apparatus to be protected, and the other end is earthed. In all the arrestors, this is common. One end is connected to the line or apparatus to be protected, and other end to the earth through the equipment body or through the wire itself. So during the normal operating conditions, there will be no arc between the gaps, but when the fault occurs, arc develop between the gaps A to B, so which will follow the B to C and will goes to the ground from the output wire. Okay. When the arc distinguish, when the fault goes, because surges are of temporary in nature, it is the surge remains for a shortest possible period of time. So when the surge disappears, the current tends to this shunt resistance came into play their role. It will limit the current when the surge goes out and removes this spark from these B to C terminals, whereas A to C terminal spark also goes out. Okay, so arc is automatically disappears. So this particular type of arrangement is used for voltage levels up to 33 kVs. Okay, this multi-gap arrestor. So there is another category of arrestors is expulsion type arrestor. This is the expulsion type arrestor. This is also called as a protector tube. It is also used for the voltages up to 33 kV. So both multi-gap arrestors or expulsion type arrestors are the main arrestors available in the market. It has certain advantages and limitations also. Let us look at this diagram. So expulsion type arrestor is also used as protector tube. So by looking at this diagram, what we notice? By looking at this diagram, the concept is same, principle of operation is same, one end to the line or the equipment, other end to the earth. So this is a backup protection is used as a rod gap, and this is the protector tube or expulsion type arrestor. So there are two electrodes are separated by the internal gap, and it is enclosed in a fiber tube. Okay. When a fault occurs, the arc gets stuck between the two electrodes, and the from the bottom electrodes, the gases get discharged out. So the major advantage of this particular type of protection is its speed of operation. The speed of operation is very fast when the surge is over. It is rapidly quench the arc, but the only disadvantage is the fiber material. The fiber material gets burned out or decomposes with every operation of this lightning arrestor. So the fiber material may break out and make the lightning arrestor useless. So this is the arrangement showing the tower arrangement. This is how the protector tube and the protector tube is connected between this cross arm and this cross arm. So this is the supporting structure. This is the cross arm. Insulators are laid to this cross arm. The protector tube is placed on the supporting structure, and this is the second line of defense available. Okay. सो ये लाइटनिंग एरिस्टर्स, ये सपोर्टिंग स्ट्रक्चर, ये क्रॉस आर्म है, तो इन दोनों के बीच हम प्रोटेक्टिव ट्यूब यूज़ कर सकते हैं एज अ मेन एरिस्टर्स. फॉर द बैकअप हॉर्न गैप एरिस्टर्स आर यूज्ड विद द लाइटनिंग एरिस्टर्स. The only disadvantage is porcelain material, the fiber material get decomposed with every operation of fault, lightning arrestors. So the last but not the least, the category of arrestors are the valve type arrestors. So they are of two types and are operate on the high voltages. It basically consists of two things: the non-linear resistors in series. In non-linear resistor is connected in series with the series gap. So these are of two types: station type and line type. Station type can be used for voltages up to 220 kV, whereas line type are used for voltages up to 66 kV. So let us look at this particular diagram for the line type arrestor, valve type arrestor. So by looking at the diagram for the valve type resistors, it is showing the equivalent circuit in the right hand side. So it is simply consists of a set of non-linear resistors with the spark gap in series and connected with it. The one end is connected to the line and other end is connected to the earth. So non-linear resistance means when the current increases, the resistance decreases, and when the current decreases, the resistance increases. So it is a there is a particular application of non-linear resistors. So here you can see the non-linear resistors are connected in series with the spark gap. Spark is dwelled between these gaps, and all the assembly is placed in a porcelain housing. So this is how this arrestor is constructional details. So this is all regarding the lightning arresters. So today we are concluded with the lightning arresters. Now in the next lecture we will discuss regarding the surge absorber. Thank you guys.